The b part, if we look at this, I'm not going to say it's equal to 0 over 0, but if we make the observation, if you evaluate this thing at 2, the numerator, 2 squared is 4, 3 times 2 is 6, 4 minus 6 is negative 2, and negative 2 plus 2 is 0. So the numerator is approaching 0 as x approaches 2. The denominator is approaching 0 as x approaches 2, so it's an indeterminate form of type 0 over 0. So what we want to do is come up with a function that agrees with this function, well, basically everywhere except possibly at x equals 2, where this one's undefined, but this other function won't be undefined at 2. And we factor. This is the limit as x approaches 2 of x minus 1 times x minus 2 over x minus 2. This is equal to the limit as x approaches 2 of, and here's where we're actually using this theorem. X minus 1 times x minus 2 over x minus 2 is equivalent to x minus 1 because they have exactly the same value for all values of x for which they're both defined. It's just that the top one is not defined at 2 and the bottom one is defined at 2. That's the only difference. But you pick an x any x other than 2, they'll have exactly the same value. If we pick x equals 3, for example, and we plug 3 into this one, we get 2. If we plug in 3 into this one, 3 minus 1, we get 2. So they have the same value for that value of x and for all other values of x except 2, the number 2. But the top one's not defined at 2, but this one is. So now we plug in the 2. 2 minus 1 equals 1. So if there is a factor of the numerator and a common factor of the denominator that's driving both the numerator and denominator towards 0, if we can factor that factor out of both the numerator and denominator and then divide them out, then it may be that neither the numerator nor denominator has to go to 0, but we can come up with well, not an indeterminate form, but a real number that is the limit. With a little synthetic division, we can take a few constructive steps toward factoring this. So if we want to, if we realize 1 is a 0, we can divide this by x minus 1 using synthetic division. Let's do, well, 1 is a 0, both of them, so I'm going to do them separately. Let's try the numerator. 7, negative 26, 29, negative 10. Bring down the 7. And how do we do this? Multiply and add, and multiply and add, and multiply and add. So 1 times 7 is 7, and we add to get negative 19. 1 times negative 19 is negative 19. We add to get 10. 1 times 10 is 10, and we add to get what better be 0. If it's not 0, something has gone terribly wrong. So we can now factor the numerator. This is the limit as x approaches 1 of x minus 1, that's the factor because 1 makes it 0, and the other factor is 7, negative 19, 10, 7x squared minus 19x plus 10. So that's a big time step because we're more comfortable factoring quadratics than we are factoring cubics. Do the same thing with the denominator. Trying to put it maybe to the side of it so we don't get them mixed up. I probably should be color coding it, but I'm not. 7, 16, negative 43, 20. Bring down the 7, and then 20. There we go. So x minus 1 times 7x squared plus 23x minus 20. Let's just divide out the x minus 1s and substitute 1 for x. So this is the limit of 7x squared minus 19x plus 10 over 7x squared plus 23x minus 20. And do you suppose 1 is going to make the denominator 0? I don't think it does. This is going to be 7 times 1 squared minus 19 times 1 plus 10 over 7 times 1 squared plus 23 times 1 minus 20. looks like negative 2 over 10. Negative 1/5. Yeah.